Class, it's Wednesday, April the 8th, I believe. You should have had your second test delivered to you both electronically and through the mail. You have about 8 days to do the test and get it back to me. So let me know if you're having issues not having received the test for any reason. Okay, we're studying Gauss-Jordan elimination. All we're going to do in this video is solve this problem. It's a 3x3 system of linear equations. We want to find the values, the numerical values for each of the variables, x, y, and z, so that if we find that value for x and for y and for z, and substitute in, all three of these are true statements. Now, I described to you how Gauss-Jordan elimination works. We want to get rid of terms, and specifically, what we hope we can do is get rid of these three terms, this one, and this one, so that this equation will just have z, this will have y and z, this will have x, y, and z. And if we can achieve that, it'll be easy to finish the problem. Now, we can't just erase the terms. That would change the answer to the problem. The main operation is to add a suitable multiple of one equation to another. You should review the previous video where we discussed a 2x2 system. All right, so we're going to begin by eliminating this term. And we're going to use the top equation to get rid of it. All right. Now, what would we add to negative 3x to get 0? Isn't it true that if we add 3x to negative 3x, we get 0? But we don't have 3x. So we're going to triple this equation and then add it to this one. Now, let's refer to these equations as E1, E2, and E3. All right. So our first operation then is triple this equation and add it to this one. 3E1 plus E2 replaces E2. This is going to be a challenging video for me because I have such limited board space here, but I'll do the best I can. All right, here's our scratch work. So let me move over a little bit. All right, we're going to triple each of these terms. This is a z. And then write down this second equation. We're going to add them together. So 3x minus 3x is 0. 9y minus 8y is y. And 5z minus 3z is 2z. And 15 minus 14 is 1. So this is the new equation. This is the new equation that replaces this one, the new E2. Okay. So we're going to copy the system over. And replace this equation with this one. Okay. So now we're going to get rid of this term. We want to add something to x to get 0. Well, that would be negative x, wouldn't it? X minus negative x is 0. We don't have negative x, we have plus x. So we're going to multiply by -1 and then add to this one. In other words, we're going to change the signs of this equation and then add that to this equation. So the scratch work looks like this. Minus x plus 3y plus z is 5. Okay, all I've done is I've written this equation down and changed the sign of each term. All right, let's add them together. So x minus x is 0. 3y, whoops, I missed a sign change. X minus x is 0. Y minus 3y is minus 2y. And z minus 4z is minus 3z. And 5 and I missed another sign change. So -5 plus 6 is 1. So this is the new E3. New E3. Okay, so what was the operation here? We multiplied E1 by -1 and added it to E3. And this is our new equation. So we have to copy the whole thing over again. Don't try to take a shortcut. Copy the whole thing, the entire system. So -2y minus 3z is 1. Let me just see if I'm on track here. I am. Okay. So now let's get rid of this term. Now, we don't want to use this equation to clear this term because that would reintroduce an x term. We want to use this equation to clear this term. So we want to add to -2y and get 0. What do you add to -2y and get 0? Well, plus 2y, of course. So we double this equation and add to this one. So the operation is twice E2 plus E3 replaces E3. Copy over the first two. All right, I'm going to skip the scratch work. I've already done 2 steps for you. You should be able to follow this. 2y minus 2y is 0. 4z minus 3z, I'm doubling this term. 4z minus 3z is z. And double this and add to that. So 2 plus 1 is 3. Okay. We're pretty far along now. We have a triangular system. So we're now going to work from the bottom up. So I'm going to have to erase here. So the second part of the solution is called back substitution. So we know that z is 3. So we take the value 3 and put it here. Okay, so y plus 6 is 1, right? 2 times 3 is 6. Y plus 6 is 1. Now subtract 6 from both sides, so y will be negative 5. And so now we go to this one, and x plus 3 times negative 5 plus 2 times 3 is, this one. X plus 3 times negative 5 minus, I was looking in the wrong place there. So z is 3, is 5. So 3 times negative 5 is negative 15. So negative 15 minus 3 is negative 18. And that's right. So x minus 18 is 5. So now we add 18 to both sides, and we see that x is 23. So we've solved this problem. Now, when you're done, you can check your answer. Go back to the original system and substitute these numerical values into each of the equations. Let's just do it for the first one. So put these numbers in this top equation here. So what does it say? 23 minus 15, 3 times negative 5. 23 minus 15 minus 3 is 5. 23 minus 15 minus 3 is 5. That's correct, isn't it? And you can do this. You can and should do the same for the second and third equation. Take these numerical values and substitute them in. Just verify that you have the right answer. Okay. Now this isn't on your second test. It's on your fifth quiz and your final exam. I would go ahead and spend a little bit of time on this because we're having issues with our videos. They seem to be disappearing, and then we recover them. So before this has a chance to get deleted from the internet or the cloud or wherever, spend a few minutes with it. And but your main effort, of course, is right now is that second test that you're working on. All right. See you next time.